Yes, rewiring the circuits to meet today's code is required. The National Electrical Code, or NEC, addresses branch circuits serving kitchens. Article 210.11 states that branch circuits serving kitchens shall be provided with at least two 20-ampere circuits. Article 210.11c3 indicates that in dwelling units, each bathroom shall be supplied by a minimum of one 20-ampere branch circuit. Article 406.3d specifies that no receptacle shall be connected to more than one branch circuit. The NEC requires separate circuits for kitchens and bathrooms for safety reasons. Kitchen circuits need to support high-power appliances like ovens and refrigerators. These appliances require dedicated circuits to prevent overloads and fires. Bathroom circuits also need to support appliances like hair dryers and curling irons. These appliances can draw high currents, so a dedicated circuit ensures there is enough power and prevents overloads. If the wiring is not corrected, several consequences may arise. Firstly, a safety hazard exists. Using an improperly wired circuit can overload the circuit, causing electrical fires. Secondly, it is a code violation. Failure to comply with the NEC can result in permit revocation, fines, and a red tag on the property. Thirdly, tenant safety is at risk. Maintaining safe and code-compliant wiring is essential for the safety of tenants. Recommended actions include firstly, contacting the inspector to clarify the issue and discuss possible solutions. Secondly, hiring a licensed electrician to inspect the wiring and rewire the circuits to meet the NEC requirements. Thirdly, obtaining a permit for the work to ensure it is done according to code. The importance of dedicated circuits in kitchens and bathrooms is rooted in preventing electrical overloads and ensuring the safe operation of appliances. Kitchens typically house several high-wattage appliances that can draw a significant amount of current simultaneously. A dedicated circuit prevents the risk of overloading a shared circuit, which could lead to overheating, trip breakers, and potentially electrical fires. Similarly, bathrooms often have appliances like hair dryers, curling irons, and electric heaters that demand substantial power. A dedicated bathroom circuit ensures these appliances can operate safely without causing the circuit to become overloaded. The NEC stipulations regarding kitchen and bathroom circuits are designed to minimize these risks and protect occupants from electrical hazards. By adhering to these code requirements, electricians can ensure that electrical systems are installed and maintained in a manner that promotes safety and prevents potential accidents. When evaluating existing wiring in older buildings, it's crucial to assess whether the circuits meet current NEC standards. If deficiencies are identified, such as shared circuits between kitchens and bathrooms, it's essential to take corrective action to bring the wiring into compliance. This may involve rewiring circuits, installing dedicated circuits for kitchens and bathrooms, and upgrading electrical panels to accommodate the increased load. The process of rewiring circuits should be performed by a qualified and licensed electrician who is familiar with the NEC requirements and local electrical codes. The electrician will conduct a thorough inspection of the existing wiring, identify any deficiencies, and develop a plan to rewire the circuits in accordance with code. This may involve running new wiring from the electrical panel to the kitchen and bathroom areas, installing new outlets and fixtures, and ensuring that all connections are properly made and grounded. In addition to rewiring the circuits, it's also important to ensure that the electrical panel is adequately sized to handle the increased load. If the panel is too small, it may need to be upgraded to a larger capacity panel to accommodate the additional circuits. The electrician will assess the existing panel and determine whether an upgrade is necessary. Before commencing any electrical work, it's essential to obtain the necessary permits from the local building department. This ensures that the work is performed in accordance with code and that it will be inspected by a qualified electrical inspector. The permit process typically involves submitting plans and specifications for the electrical work to the building department, paying a permit fee, and scheduling inspections at various stages of the project. During the inspections, the electrical inspector will verify that the wiring is installed correctly, that all connections are properly made, and that the electrical system meets all applicable code requirements. If any deficiencies are identified, the electrician will be required to correct them before the final inspection is approved. It's important to note that the NEC is updated every 3 years, so it's essential to stay current with the latest code requirements. The electrician should regularly attend continuing education courses and seminars to learn about the latest changes to the NEC and to ensure that they are providing their customers with the most up-to-date and code-compliant electrical services. In addition to the NEC requirements for kitchen and bathroom circuits, there are also specific requirements for ground fault circuit interrupter, or GFCI's, protection in these areas. GFCIs are designed to protect people from electrical shock by monitoring the current flowing through a circuit and detecting any leakage to ground. If a ground fault is detected, the GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing a potentially dangerous shock. The NEC requires GFCI protection for all 125-volt, 15 and 20 ampere receptacles installed in kitchens and bathrooms. This includes receptacles located near sinks, countertops, and other areas where water may be present. GFCIs can be installed as either receptacle-type devices or circuit breaker-type devices. Receptacle-type GFCIs are installed in place of standard receptacles and provide GFCI protection for that specific receptacle. Circuit breaker-type GFCIs are installed in the electrical panel and provide GFCI protection for the entire circuit. When installing GFCIs, it's important to follow the manufacturer's instructions and to ensure that they are properly grounded. The GFCI should also be tested regularly to verify that it is functioning properly. To test a GFCI, simply press the test button on the device. This should trip the GFCI and interrupt the flow of electricity to the receptacle. To reset the GFCI, press the reset button. If the GFCI does not trip when the test button is pressed, it may be defective and should be replaced. In addition to GFCIs, arc fault circuit interrupters, or FSIs, are also required in many areas of the home. FSIs are designed to protect against electrical fires caused by arcing faults. Arcing faults occur when electricity jumps from one conductor to another, creating a spark that can ignite nearby materials. The NEC requires FSI protection for all branch circuits that supply power to outlets installed in dwelling units. This includes circuits that supply power to bedrooms, living rooms, dining rooms, and other areas of the home. FSIs can be installed as either circuit breaker type devices or outlet type devices. Circuit breaker type FSIs are installed in the electrical panel and provide FSI protection for the entire circuit. Outlet type FSIs are installed in place of standard outlets and provide FSI protection for that specific outlet. When installing FSIs, it's important to follow the manufacturer's instructions and to ensure that they are properly grounded. The FSI should also be tested regularly to verify that it is functioning properly. To test an FSI, simply press the test button on the device. This should trip the FSI and interrupt the flow of electricity to the circuit. To reset the FSI, press the reset button. If the FSI does not trip when the test button is pressed, it may be defective and should be replaced. Proper electrical wiring is essential for the safety and well-being of building occupants. When electrical systems are not installed or maintained properly, they can pose a serious risk of electrical shock, fire, and other hazards. By adhering to the NEC requirements and using qualified and licensed electricians, building owners can ensure that their electrical systems are safe and code compliant.